wheel problem that was from our homework a couple days ago. The Wonder Wheel Ferris wheel of Coney Island has a radius of about 68 feet and is 15 feet off the ground. After a person gets on the bottom car, the Ferris wheel rotates 202.5 degrees counterclockwise before stopping. How high above the ground is the person when the wheel stops? Well, the book gave you a picture, but it's so helpful to draw your own. Even the process of making your own can kind of help you think through it a little bit. So there's my Ferris wheel. And I know that the radius of this Ferris wheel is 68-ish feet along those lines, here to here. So that's about 68 feet. We'll call that 68 feet. It also says the Ferris wheel is 15 feet above the ground. It has to be a little bit off the ground so it can actually rotate. So the space, like from here to here, it's 15 feet. Now we've got somebody who's in a car, and that car starts on the bottom. And going counterclockwise, they travel 202.5 degrees. Well, from here to here would be 90, and from here to here would be 180. So you go a little bit further, and that total space there is 202.5 degrees. We want to think about this like we have an XY axis. So like the x-axis is running through there, the y-axis is running through there. And so the origin is right there in the middle. Well, this whole curve here, from here to here, is 202.5. What's this little triangle going to be? What's this piece here? Yeah? 22.5. That little bit in there is 22.5. So what's this bit here?
Wait, so how did you find that it was 22.5?
It's just the number minus 108.
Right? From here to here is 90. From here to here is 180. So that must be the extra 22.5 to each
So you can't just do it where it's like this. I guess you can't assume that it's the same size as this place. It's up to be 68 feet.
Right. Yeah. Okay, so this is 22.5 in here. Then what's this angle here?
90 minus 22.5.
And what is 90 minus 22.5? 67.5. So that angle is 67.5, and that's basically our reference angle. If I want to find the height of this spot right here, I want the sine of 67.5. The sine of 67.5, if you're in degrees, put it in degrees, and I do the sine of 67.5. And I get 0.9238. Well, that 0.9238 would be if I was on the unit circle. But I'm not on the unit circle because this radius is 68 instead of 1. So I take that 0.9238 and multiply it by 68. And I get 62.8 feet. That's what this height right here is. This height right here is 62.8 feet. We also could have thought about just this right triangle here and found the height of that right triangle using sine, because sine is the opposite over the hypotenuse. That's 62.8. There was an initial 68 and then an initial 15 before that also. So you add 68 and you add 15.
Wait, Chris, would it still be 68 feet from the middle, even though it's not going from the origin?
That's a great question, and it would be 145.8, because whatever space you lose here, the 15 would make up.
Okay.
The idea is from here to here is still 83, no matter what, and then there's that other 62.8.
Okay.
Yeah?
So why is the blue line on the top not 68 and 62?
Well, because if you think about the radius, I'm going to draw another circle to try and explain this. If you think about the radius, if this radius is like 10 feet, we'll keep it simple, we'll call it 10. If this radius here is 10 feet, right now, it's 10 feet high. It's going straight up. But even though the length is still 10 feet, as it moves along the circle, the height gets shorter. You see that if you think about this triangle here,
How can the height get shorter if the circle's the same?
because the height is just that length right there. Because of the angle the radius is moving at, the height can change its length. The height can get longer and shorter, even though the radius is changing. See how this height is longer than this height? If I keep on sliding it around, well, now the height's really short, even though the radius is the same. So it's because there's this, the circle is dropping.
So 68 on that circle is this part.
68 is the radius. Yeah.
So it's the slanted part on that one?
Yeah, that right there is 68. And
I know, but
this
on
right
that
here
side.
is 68.
Okay.
But the height is 62.8. Okay, any other questions about this one? Find this side length over here. Well, how would we find, I'll call it C. I'm not asking for the area, I'm asking for the side length. How can I find that side length, yeah?
Well, I guess, well, the formula is that I would use is squared plus b squared equals c squared.
You'd use the Pythagorean theorem. That only works in right triangles.
And you're not saying that it's not a right angle.
We don't know if it's a right triangle or not. Sure doesn't look like one. Yeah?
It's 1/2 5 times 7 times the sine of 36.
What you just told me, 1/2 times 5 times 7 times the sine of 36, is how to find the area. I'm not asking for the area.
Was the homework asking for the area?
Some of it was, not all of it. Just a few questions. Yes, Sarah?
You're just looking for the side length.
Just C. I want side length C.
Cosine 36, or you go over 7 equals like cosine 36, or cosine 36 equals c over 7.
Cosine 36 equals C over 7 because that's the hypotenuse.
Oh, it's
Not a right triangle. We can't use trig because it's not a right triangle. Yeah? Sure, law of sine. Set that up for me.
So it'd be sine 36 over c equals.
Law of sines only works if you know an angle-side pair. If you don't know the values of an angle and a side that are opposite each other, law of sines doesn't work. This is the last triangle that we're not able to solve. If we don't have an angle-side pair, you can't do anything yet with the tools we have, but there's something called the law of cosines. The law of cosines is the last trig tool we're going to use for these triangles.
When we have our unit test, are we going to get a paper like we did last time? So we're going to need them.
All you really have to know is law of sines, law of cosines, symmetry.
We are going to
No paper. Law of cosine starts very Pythaggy, c squared equals a squared plus b squared, but then it does minus 2ab times the cosine of c. It doesn't actually matter which is side c and which is angle c. In your book, they're going to give you 3 formulas, one of the c squared, one of the b squared, one of the a squared. It doesn't really matter. All that matters is you're always trying to work with an angle and a side that are opposite each other. Okay? The things on the outsides of this formula are always going to be the angle and the side that are opposite each other. So right now, I'm trying to solve for side c. I know that side c squared equals a squared, doesn't matter which one's a, plus b squared, doesn't matter which one's b, minus 2 times a times b times the cosine of c. Now, don't
Don't
see
we
is
know
36.
that 5 is C? Because it's on the longest side.
No, A, B, and C only means the longest side if you're on a right triangle.
Okay, can you please explain how that's not the right triangle?
There's no right angle anywhere.
But it has the like little quantity thing.
Well, sure, but it's not 90 degrees. has to be 90 degrees for it to be a right triangle. And we don't, one of these might be 90 degrees, but we don't know. We can't assume it's 90 degrees and go with it. Okay, so we can't use like regular sine, cosine, tangent, or the Pythagorean theorem, because we don't have a right triangle, because we don't know that we do. So, c squared equals 25 plus 49 minus 2 times 5 times 7 is 70. 25 plus 49 is 74. Please hear this. You cannot do 74 minus 70 ever with these law of cosines. Because this is multiplication. And you have to do multiplication before you can do subtraction or addition. So don't ever try and do 74 minus 70 is 4. But at this point, I'm just going to plug it into my calculator. 74 minus 70 times the cosine of 36, 17.37.
You make those videos? How does it pick your voice?
My computer has a microphone catching it.
Oh.
Yeah, so
You normally make them like when they're going to the classroom?
normally, yes. Yeah, it depends on if it's like I want to teach a lecture or if I want to just record class. And today I think it'll work well enough if I just record class. But for like the unit circle day, that was the day I just wanted to have like me teaching without the interruptions or the questions you can't always hear and all the distractions.
So they can hear all of us.
Yes. So like we heard Brett rifling through his chips bag. Really, really clear. Just Brett going. It's awesome. Thank you.
Yeah, right.
If c squared is 17.37, Brett Prue. Is that what we're talking about? Brett Prue?
Brett Thomas Prue.
That one. Okay.
Hi, Julia.
Then I do the square root of that answer. And I get 4.2. So c is about equal to 4.2. Here's the best thing about the law of cosines. You only have to do it once. Now I can do law of sines. If I want to find this angle up here, I'll call it angle A. I guess it was B the way that I set it up. I'll call it angle B. Well, now I can do law of sines. Sine of B over 7 equals sine of 36 over 4.2. Okay, so you only have to do law of cosines once. But it works when you don't have an angle-side pair. So it works for side angle side or side side side. Yeah, side angle side or side side side, it works. Yep, all those ones. Question there? Okay, next. Here we're going to find an angle. Look at the side 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 triangle. We're going to find one of the missing angles. Let's find this one. We'll call this angle A. Doesn't really matter what I call it. Well, now I have 11 squared. So remember, these things are going to be the ones that are opposite each other. So even though that's side A instead of side C, it doesn't matter. I have 11 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of A. How do I? Jog. Seriously, I don't care. Can I go conversation? You okay? Okay. Is everybody okay with how I set this up? I just plugged in C's and A's and B's and C's, and I'm trying to find this angle A now. Well, 11 squared is 121. 6 squared is 36. 8 squared is 64. 2 times 6 times 8 is 96.
So if you plug if you like switch around, it doesn't matter.
Yeah, these two here don't matter because it's addition, but this one definitely does. Because I'm trying to find angle A. So I'm trying to find angle A.
So how do you know that C is the longest side?
I don't. Okay, stop thinking about longest side because we're not doing right triangles right now. We're just doing any triangle.
Okay, then how do you know that 11 is C?
Good. That's the question to ask because I'm trying to find this angle here and that's the side opposite. Just like how C and C were opposite each other. Okay. So 121 equals 36 plus 64 is 100. Now what? Yeah, what? Subtract
Oh,
what?
so you can't just plug in your calculator now? Oh, no.
No, because I don't know what A is. So I cannot do 100 minus
Yeah, I thought
96,
that's the first one.
but I can subtract 100. So 121 equals negative 96 cosine A. Divide both sides by negative 96. I can't divide by cosine.
Wait,
Wait, 121 minus 100 is not 1.
Thank you.
Where is he used?
oh, you were just trying to.
Yes, it's just 21. Yeah, I apologize for that. Divide both sides by negative 96. You cannot divide by cosine. Trying to divide by negative 96 cosine doesn't make any sense. It has to be a cosine of something, but we don't know what that something is because we don't know what this A is. You can never get rid of a cosine just by dividing it. So what I have right now is negative 21 over 96 equals cosine of A. I can't get rid of that cosine by dividing it.
Inverse.
I do inverse cosine. Inverse cosine is how I undo regular cosine. So now I have cosine inverse of negative 21 over 96 equals the cosine inverse of the cosine of A. You don't have to write this the way that I'm writing it. I'm writing it the long way, just so you can
What's
see it.
boss?
It's close.
It looks like boss.
Sure, but Shauna, just think about what it should be, right? Just take a second and think about what it should be. Goodness. Ugh.
I thought maybe it was like short or something.
That's gonna be good.
Short for Rastafari or something.
Yeah.
Yeah. You can skip that step I just did and jump straight here. Okay, cosine inverse of negative 21 over 96 equals A, and now I can find my angle. $102.6. Now that makes sense. It's going to be the biggest angle that's opening up to the biggest side. Right? Biggest angle, biggest side, so that's reasonable. Now from here, I can find the other angles if I want by doing law of sines. Law of cosines works every time. For any triangle, you could use the law of cosines, but it's the worst. It's the longest and the hardest and it's the most complicated. That's how it goes with math. The things that work everywhere are the worst. And things that only work in a few cases are the easiest. That's why like trig, just doing regular sine is really simple, but only works on right triangles.
You should probably make that different. Make it so it's all easy.
Yeah, good.
Does that change how math works?
They should just change like the logic of the universe. They
Yeah.
should fundamentally change how God created the world to make things easier.
Just for fun.
Beautiful.
That'd be nice.
Profound.
Question about this? Also, they should probably have a trig function called Ross. That's the other thing they should do. It's like a character from Friends or something.
Okay, but that looks exactly like, that does look like what you wrote.
Uh-huh.
It doesn't have a curve at the bottom. Like,
Okay.
just assume
It's not
the
rock.
C.
We can now solve any triangle in the world.
Well,
With our trigs, our law of sines, our law of cosines. We can throw any triangle at us with only 3 bits of information, any 3 bits of info, and we can find stuff. So now we can start seeing how this is useful. This is how these things actually work now. This is how these things are done in the real world. This is how they were before satellites. 2 forestry lookouts are posted 150 miles apart. The northern lookout spots a fire at an angle of 38 degrees from the southern lookout. The southern lookout spots the same fire at an angle of 55 degrees from the northern lookout. How far is the fire from each lookout? So we have one lookout tower here, right out in the forest, and one lookout tower here, and they're 150 miles apart. And then way out here, there's some big fire. And it's a bad thing because little birds and little squirrels are all going to lose their homes. And it makes us really
Birds can
sad.
fly away.
But they still lose their home.
Their home.
They can build a pod.
Fine, but they still lost their home, Shauna. What I said was totally true. Yeah, all kinds of animals are losing their homes. And this is very sad.
How many turkeys
Why do you make such a depressing story?
Yeah, why
Because,
did you have to include
because
that?
we're going to put this fire out using math.
This is realistic.
We're going to be heroes with mathematics.
Can we do that?
Yeah, you
Realize
can
that's
throw
still in
all
water.
the birds in the
But I
lake.
want to be a firefighter.
The birds are going to be safe, Shauna. The birds can fly away.
Yeah.
They're going to be safe.
They still lose their home.
Yeah, so what's the point anymore? Yeah, they still lose their home.
They don't know where the fire.
I'm going to get going. The angle from the northern lookout to the fire from here to here was 38 degrees. The angle from the southern lookout to the fire from here to here was 55 degrees.
That picture's not greatly drawn.
So, 38 plus 55 is 93, which means that this is 87 degrees. I'm going to find, we'll call this A, and we'll call this B. I want to find those two distances. How can I find A?
You do sine 38 over B and then sine 87 over 150.
I'll find the B this way. Great. Cross multiply and divide. Sine 38 times 150 divided by the sine of 87 equals B. So I'm going to do sine 38 times 150 divided by the sine of 87. And that gives me 92.5. So this distance here is 92.5 miles. Somebody else, how am I going to find A?
Same thing, but instead of using B, use A.
Go for it.
So sine of 55 over A equals sine of 87 over 150.
So I do sine 55 times 150 divided by sine 87. I can actually just change some numbers in my previous entries. Hit second enter and change that 38 to a 55. This gives me B. B is 123. Or A, sorry. A is 123 miles. And now that we have these two distances, from these two fixed points, we can say exactly where that fire is. We can say exactly where to send your firefighters to save the little animals. Okay, and I hope you see how powerful that is. Without actually running to the fire, or even be able to tell this distance by looking at it, by just seeing two angles and knowing the distance between these two lookouts, and we can measure that pretty quickly, we can find any location we can see clearly on a map.
Do they actually do this in real life?
Yes, if you go to lookouts like on tops of hills and mountains in Oregon, they have like this 360-degree view, and they've got a tool in the middle, it's called a sextant or something like it, and they look around and they find things. And now they don't need the Trig by hand so much anymore because they can do it all with satellites, with radio, and they have thermal imaging stuff and all that. But this is how it was done for a long stinking time.
Weird.
Awesome.
So
Yeah.
it's just these like normal lookout tower dudes, like
Mm-hmm.
national security people. Just do that.
Whoa.
Yeah, some Trig. And this was a very hard Trig, right? Got a calculator, do a couple steps, and you got it.
Well, it's kind of hard.
Well, okay, but just sure. Question about that at all? Another one.
Yeah.
Yes, we know.
We're gonna do 4 total.
Okay.
You're standing 200 feet from the base of a building. The angle of elevation between the ground and the top of the building at the point you were standing is 73.6 degrees. How tall is the building? Angle of elevation means the angle above horizontal. The angle of elevation is the angle above horizontal. And the angle below horizontal is called the angle of depression. If you're looking up, it's an angle of elevation. If you're looking down, it's an angle of depression, all from the horizontal. So what we know is there's a building out here. It's 200, and we're standing 200 feet from it. And from the ground, the angle to the top is 73.6 degrees. And again, I know that picture's not accurate, and I don't care. Got a triangle and a building, I can play with this now. Well, how tall is the building? I'm trying to find this x. Trying to find that height. How am I going to find it?
Do sine, wait, no, tangent of 73.6 equals 200 x over 200.
Opposite over adjacent. Because we have a right triangle, we can use basic trig. So now I
Yeah,
do,
but how do you know it's a right triangle?
well, all I care about is the up and down part. And the up and down is vertical, and so vertical makes it right angle. Even if the building itself isn't a right angle, I care about the height from the vertical spot. 200 tan 73.6 equals x. $679 feet. 679.5 feet. Again, I hope you see how useful that is. You can measure the height of something without actually climbing it, without trying to run a tape measure from the top to the bottom. You can just take a few steps from the ground that you can measure, calculate an angle with a simple little tool, and find a height of something. Question there? Okay. This next one's real similar, just a little bit different. You're standing 50 feet from that tree over there, and you're 6 feet tall. The angle of elevation from your eye to the top of the tree is 64.4 degrees. How tall is the tree? So here are you. And here's a nice little tree. Branches coming out. It's just got a lot of leafy action going on.
That's tree.
Very nice tree, I agree. And we'll have these meet at the same point. You're trying to find from your eye to the top of the tree. Every other class I haven't needed to use my straight edge tool. I'm gonna do it one more time. There we go. From your eye to the top of the tree, you're trying to find the height. You know the angle from here to here was 64.4 degrees.
Maple.
I'm gonna find this height. Height h.
That's all. What does that one side say? That's
Height h.
oh.
We're trying to find.
Wait, could you not use like the 6 feet, how tall you are anyway?
Yeah, that's a big part of it. I mean, we're gonna say like to our eye is 6 feet.
Okay.
So we'll say that this right here is 6, which means that there's a gap here that's 6.
That little thing that's 90 degrees.
Could you make another triangle from your eyes to the bottom of the tree and then find the length there by...
Yeah, we're playing with that yellow triangle now. So I can do the tangent of 64 equals x. I'm going to call it x. So this length here is x.
Wait, do you have to divide 64.4 in half?
64.4. No. Why would I divide it in half?
Because you're only doing half the triangle?
I'm not doing half the triangle. I'm doing this whole triangle, the whole big yellow triangle that I'm playing with.
Okay.
And I know that we are 50 feet from it. So I know this down here is 50. So the tangent of 64.4 equals x over 50. So 50 times the tangent of 64.4 equals x. Calculate that. I get 104.35, and I add 6 to that. Because that just gave me this length here. I still have to tack on this 6 here. So we add a 6, and it's 110.35. And that's worth knowing because there are some tools that you do by sight when you're holding them. So you just kind of stand there and look at the thing and then figure how far. Yeah. Question about that at all? Okay, here's the last one. It's my favorite. We're going to figure out how tall that mountain over there is. I don't know. There's some mountain. We're going to measure its height.
Say a little football over that mountain.
I bet you could. You and your uncle.
Yeah.
We have no stinking idea how far we are from the mountain. Here's the thing. Uncle Rico's Street. Yeah, let's try and keep up.
That was good. I like that. So quick. You just like knew what he was thinking about.
Oh, what else? It's like that.
It's not like I'm reading his mind. I'm just hearing what he's saying and knowing what he's referring
Well,
to.
yeah.
Somebody else that has.
I thought he was like joking around.
No.
He knows what's up.
I know what's up. I always know what's up.
Next Napoleon Dynamite can be written on that.
That is so topic. That was so random.
No, Napoleon Dynamite isn't off topic. What's off talk about Napoleon Dynamite here?
They just said Nick looks like Napoleon.
Right, but we were just
talking about Napoleon Dynamite.
Oh, you know.
Wow.
I swear.
Oh, the guy in the van.
Uncle Rico. Yes, Uncle Rico. I'm gonna get fired if one of my, if like Mr. Conroy pulls this up on YouTube and looks at it, he's like, "This is the worst class I've ever heard." I'm gonna fire this guy.
Well, now he can hear you say that.
Well,
Yeah.
I think you're awesome.
So now he knows I know it's coming.
Now he's gonna get that.
He
Yeah.
knows about Napoleon Dynamite.
So yeah, my guy's really tall compared to this mountain. I get it. We're standing. We don't know how far from this mountain.
You go to football.
Stop. We don't know how far we are from the mountain because you can't really do that, right? Measuring your paces from here to whatever mountain you're looking at is not easy or accurate or worth doing. But what I can do is I can measure the angle from the ground to the top of the mountain. Let's say that this angle here, I'm going to write this real small, is 20.1 degrees. And then I can take a few steps closer. I take 200 paces closer, and I make another angle to the top of the mountain. And this angle here is 20.3 degrees. What I'm trying to find is the height of the mountain. I'll make that blue. I'm trying to find this height, h. How am I going to do this? I know my triangles aren't perfect, and not everything's looking really great, but you get the idea of what's going on here. How am I
Is
going
the
to find
200
that?
the whole bottom length or just in the red
Just
part?
this little red stuff.
So you're trying to find the height, but you don't know the little part under the green?
I don't know the green length on the bottom. Yeah?
So like the line from the red to the green, we
Uh-huh.
can figure out what that other angle is.
We can. What is it?
180 minus 20.3.
That little bit in there is 180 minus 20.3, so it's 159.7. Okay, how does that help me? It will, but now what? Yeah.
Oh,
Uh-huh.
so you can figure out the third angle in that triangle.
This little ditty here.
And then you can figure out the other, then you figure out from the green to the blue.
Sure. So if this is 159.7, this is 20.1, that's 179.8. So this is 0.2 degrees.
Wait, can you figure out the whole angle from the red to the blue?
That is very
You have the 20.1 in the corner and then it's right angle.
Yes.
So
We could do this whole entire angle here. We could do red to the blue.
yeah.
But that's not actually going to help us at all because we don't know that length. You see? So we
Yeah,
could
yeah,
get
yeah.
it, and we might as well. You can find whatever you can find, but I'll tell you right now, it's not going to be what helps us.
Okay.
Do you need to find the side of the red?
I want to find the big long red side now. Yeah?
Okay, so I have a question.
Uh-huh.
How, because we were like dealing with not right triangles and now we are, like how do we know? Is it given to us?
Because we're trying to find a height, we can assume the height's going vertical. That's the idea of a height. The height is the vertical distance.
But on that first triangle that we did, it was vertical and then you're like, it's not 90, we can't assume.
This one here?
Yeah.
Nothing there is vertical.
It's crooked.
That is it.
Michelle, see how this thing snaps? It snaps to vertical. Tell me where you see something vertical.
How?
Nothing vertical there.
I just. Stop laughing. This is why.
Okay, so when we have a height, that literally means we're going straight up from the ground. Okay, straight up from the ground is our definition of vertical. That's 90 degrees. Okay, I want to find this.
So could you figure out like the angle at which a plane takes off doing this?
Yes. Yeah, Tyler, go ahead.
You do the law of sines now
Uh-huh.
and find
So I know that the sine of
point
Point
two.
point
The sine of
two,
point 200
the sine of 0.2 over 200
equals the
equals
sine
the
of 150.
sine of 159.7 over x. So I solve this by doing 159.7 times 200 divided by the sine of 0.2. Forgot the sign in the beginning. Insert sign here. And insert parenthesis there. Sine of 159.7 times 200 divided by the sine of 0.2. 19,878. This is 19,878 feet.
One tall person.
What are you talking about?
That's the distance from the person to the top of the mountain.
Oh my god. What really is that?
That through.
This is good.
It's not really like all
Did
that.
you hit the head with a golf ball?
I don't know if you're gonna be able to do this.
Just, what am I doing with my life? It's like, how can I try and teach you guys anything? We don't know what vertical means. We think we see the word Ross. We think a person's 20,000 feet tall.
At least I
Napoleon Dynamite.
Napoleon Dynamite's like the most traction we've had all day. I got confused. Let us finish this problem. I now have the length of this long red side. And since I have big old honking triangle here, and I have an angle and a side and an angle, I can actually do trig, regular trig now. I want to find h. Well, the sine, no, I'm sorry, yeah. The sine, the tangent of 20.1, the tangent of 20.1 is going to be opposite over hypotenuse, which is h over 1987/8, or 987. Oh, it's hypotenuse, you're right, it's hypotenuse. So I want sine, thank you.
Get ready.
So I do 19,878 times the sine of 20.1, and that's going to give me the height of this mountain.
Sorry.
6,831 feet. That's not a person, that's a mountain.
How many miles is that?
We would divide that by 5,280 to find the miles. It's 1.2-ish, I think.
Oh, that's amazing.
I was getting the person here.
Sure.
Don't hike straight up.
You don't hike straight up. That's just the elevation gain. That's not how far you're actually going. And please note I said elevation gain, not the actual elevation. Because we don't know how high we were when we started.
It's not sea level.
We're probably not at sea level. Okay. And we might hike down or hike up on our way to the mountain. But here's what I hope you realize that's so cool. Without having to walk all the way to that mountain, and without having to try and climb the mountain, and without even knowing where the center of the mountain is, by just taking a few steps forward and 2 little measurements, I can measure something that's 6,800 feet taller than I am right now.
So what does the 2 steps have to do with the 200 steps?
You have to get 1 measurement on the ground to work with. And the longer it is, the easier the calculations and the more accurate it may be. You can't just take 2 steps because then these degrees would be the same. But it's something reasonable as opposed to trying to walk your tape measure 15 miles or something. Now notice how precise these had to be. 20.1 and 20.3 are really, really close. Had this been off by like half a degree, the height of our mountain would have been off by several hundred feet. But you take your time, you do it a few times, you check your work, make sure you're being precise and careful. And you can measure things anywhere at any time with just a couple tools. Yeah?
Just like, how they measure mountains.
I'm sure at one point it was part of the process of measuring mountains. I've tried to think it through. You know, you could also like do barometric pressure to find your actual elevation when you start. So once you do barometric pressure to find how high you are, then you measure the top of the mountain based on the height you have there. And yeah, this is how heights of things can be found. It's cool. Any other questions? Okay, you're going to have a test next week, probably Tuesday, maybe Wednesday. It's just going to be on triangles. What I'm going to do is take this big chapter and split it up into a triangle half and a circle half. So all your unit circle stuff we're going to kind of put on hold for a second and come back to it. And it's just going to be sine, cosine, tangent, cosecant, secant, cotangent, law of sines, law of cosines. Yeah? Yeah, it's coming to you right now, practice test. So now I'm going to check off your homework, either work on the practice test that I give you or tonight's homework,
Is this a bit or not?
and that's it.